So it turns out, I've given a similar lecture before, and I just made up code the whole time. Stupid, not serious, just text. Turns out I was actually working on some code today. I was writing some real code today, but I haven't put it in a Git repo yet. So we can do that. We can go. I was working on this code for an inextensible beam, and a couple of weeks ago, I think maybe this organization hosted a workshop, or maybe last week, where you learned about Jupyter notebooks or IPython notebooks. Was anybody at that one? A couple of you, people know what IPython notebooks are, or Jupyter notebooks. So it turns out, I was actually using a Jupyter notebook. It's a Python code, and I was actually calling. I wrote some C code, some C++ code actually, that I call from Python. So the sort of meat of the computation is here, and then I call it from the Jupyter notebook in Python. So I take that C code and I compiled it into a dynamic library. Okay, so this is kind of typical of a project, a real small project. I have a couple of source code files. In this case, we'll treat the IPython notebook and the residual.cpp as source code files. I have a dynamic library. That's a compiled code, right? I wouldn't normally, it's a big object file. I wouldn't want to normally keep that in a repository because I can always recreate it. I can recompile residual.cpp and I can recreate that file. So I don't really want to store that. I don't want to store my source code, okay? So I have no Git repository here. I'm gonna start a new Git repository, something a folder of things, if you will, that I want to keep a history of and track changes over time. Okay, so I'm going to say git init, and that's how easy it is to create a Git repository. And you'll see I have this special sort of command prompt thing here called powerline, and it actually puts this, when I created that, it put this thing here. That tells me that I'm in the master branch of this Git repository. Okay. So master is the default branch, right? And so you can type git branch. I'm going to make the font just a tiny bit smaller. So everybody still see that okay? Just because I was typing up against that. Okay, so let's try it again. I can type git branch. It should have listed the branch as master. Oh, well, there's no commits yet. Maybe that's why. Okay, so I've initialized it with git init, and that's all you have to do, and that's how easy it is to start a new repository. Okay, so now I want to add things that I want to track. I want to track the history of. And the thing I want to add residual CPP, and I want to add this inextensible beam.fea.ipython notebook. So I'm just going to say git add inextensible beam IPython notebook and residual.cpp. And when I do that, if I type git status, you'll see that it's saying on branch master, I have 2 files that are staged for commit. These are the green ones, the 2 that I added. I also have some other files that it's just saying, look, it's telling me, look, these are in your folder. Do you want to add those for this commit or not? Okay. So a commit is like a snapshot in history, right? It's a snapshot that I want to save in history. Okay. And these usually in the context of code, this is sort of, usually a snapshot in history is when you implement some new feature or some new testing or something new and it works. You want to take a snapshot before you continue your development and possibly break something, right? So what I'm going to do now is I'm going to write, the green files are staged for commit, meaning when I type git commit, these will be the files that get committed, okay? So I'm going to type git commit. I'm just going to type that, and it's going to open up an editor, okay? So here's my favorite editor is Vim. You can set an environment variable to open up Atom or whatever your favorite editor is, Emacs. Right? I use Vim. So it opened Vim, and now I'm able to write a commit message. So let's talk a little bit about commit messages. The sort of best practice thing to do when you write a commit message is you write some short description in the first line, and then you write a more detailed. You skip a few lines and you write something more detailed later. So you're gonna my first I think it's adequate to just simply say first commit on the first line, and then say something more detailed. So add files to a knit repo for demonstration. And you could go on write, sometimes it's necessary to write 2 paragraphs there, okay? It's very important that you write good commit messages, especially when you work in team environments, because you want your teammates to know what you did on that commit. But it's also very good for your own good. The whole point of doing version control is because there's a possibility you want to go back in time to something. Well, if you don't write a good commit message, you're not going to know what to go back in time to, because you're not going to know what the commit was. Does anybody ever read the comedian XKCD? Or the webcomic? The webcomic XKCD? He has a funny one that sort of struck a chord with me. Because sometimes, especially you can be debugging some continuous integration server, and so you're changing the configuration files for the continuous integration server, and the only way to trigger the continuous integration server is to commit, right? So you have to give it a commit. So you give a commit, change Travis config, commit. Change Travis, and then it breaks, not working. Change Travis commit, and eventually you're doing the same thing. You're just debugging over and over, and you run out of things to say that are meaningful. And he has a funny one that, on the, so the first one is very descriptive of what he's doing, and they get less descriptive, and then by the last one, it's my fingers are typing words. That was his, anyway. Okay, so I have a commit message now. I'm going to write and quit my editor. And now I have committed that, and if I type git status again, you'll see my green files are gone. That's because they've been committed, and it's telling me nothing added to commit, but untracked files there. Okay, and now if I type git log, now this is the history of the commits. So this is this long thing here is the sort of the hash or the description of the commit, and I can always, using this thing, or even a short subset of it, go back in time to this commit, okay? So there you see my commit. You see there who I am and the time I did it, and the name there, okay? So, every good repo should have a README. So I'm going to add a README. So I don't have a README at all, right? So there's the files in my directory. There's no README. So I'm going to say readme.md. And I'm going to give it, so this is my inextensible beam FEA code. This code calls residual CPP. So I'm just typing some stuff in this file that is trying to be meaningful here. This code calls residual CPP from an extensible beam in Okay, so that's just a file that I added to tell people what this repository is about. Okay. So if I type git status again, you'll see that README is red. I haven't tracked it, but I want to add it to the repo. Okay, so I'm going to add it to the repo. So I'm going to say git add README, and then I'm going to say git commit. Now this time, I'm going to put the commit message on the command line. It's a short commit message. I mean, I added a README. That's really all I need to say, right? So I can, in this case, if I hit enter, it would open up an editor, and I could write a long descriptive text. Here, I know the commit message is short, so I'm just going to say git commit m add readme .md. That's going to be my commit. And now I have git log, right? So there's my first commit and my new commit. So I have all those other files in my repo, and some of them I know that I'm never going to want to track. I will never want to track a file. And so on a Mac, a shared object file, a dynamic library, always has the file extension .dylib. Okay, so that's a compiled library on a Mac. Okay, I will never ever want to add a compiled library to a repository. Okay, so there's a special file you can add to Git called gitignore. It has a dot in front of it, so it's a hidden file. So I say gitignore. And what you can do is you can then add files to the gitignore file that'll always be ignored, right? They'll never accidentally be added. They'll be taken off of that red list. And so what I can do is I can say any file with a dylib file extension, I want to ignore, right? So now if I type, all right, so you see up there I had that residual.dilb showed up in red. Now if I type git status, it's going to be gone. See, it's gone. And it'll never show up again, and I'll never be able to add dylb files to my repo, and I would never want to. Okay, so I can actually track the gitignore file itself. So I'm going to say git add gitignore, because it might change over time. It's also something I might want to store in the cloud later when we talk about GitHub. And so then I'll just git commit that. Okay. Add gitignore. So now I have another commit. So far we've just been adding files, right? That's not that useful to track the history of file additions. What's more useful is to track changes to files, okay? So let's change a file. So let's look at that residual.cpp. Because I have it open somewhere else. Let me close it. I was actually working on it earlier today. Okay, so here's my C code, and let's do something harmless. So right here in the middle of the file, we're going to add a print statement. Hello world. Okay, so now if I type git status, it tells me that I have a modified file. So this is a file that's tracked, meaning it's in the repo. It was committed previously, and you've made a change to it. Now, so it's not green, so it's not staged for commit yet. Okay, but it's been modified and it's telling me that. So it's saying, you know, you changed a file. Do you want to save that change? Right. So yeah, let's do it. So I'm going to say git. Now this time I can do something special. Since it's already tracked, right? We typed git add git commit on this file earlier. It's already a tracked file. Okay. So what I can do with that now is, instead of having to type git add because it's already tracked, I can just add an extra flag on the command line. So I'm going to say git commit. This time I'm going to say AM, right? So the -m means put a message on the command line, right? The -a means add all files that are already tracked to this commit. And so I can say, you know, made changes to residual CPP for demo. Okay, git log. There it is. By the way, there's a plethora of options you can add to git log that control exactly how much information shows up here. Okay. So now if I look at residual.cpp, I have this hello world here. Okay. But let's say that breaks my code, won't compile. And I don't know why. And I'm in a hurry to meet a deadline, so I'm not going to try to debug it. I just want to go back in time to when that wasn't there. Okay? So one thing I can do, and I mean this is maybe not the best thing to do, but one thing I can do is I can just go back and I can check out the previous commit. So the previous commit, the most recent commit is got the number 20F71D, whatever. Okay. The commit previous to that, before I made that change, has this guy, 71AA168. So what I'm going to do, I'm just going to check out that commit. Right? So I can say git check out. And the nice thing is I don't have to type out that whole thing. I could like copy and paste it or something. All you have to do is type enough of it for it to be unique, right? Which is usually just the first 4 or 5 letters. Right? So you don't have to type the whole thing out. You just so 71AA168 is probably adequate. So it's giving me some stuff about detached head. And you see my little special power line deal here shows me I was on master. That's the default branch name. Now it's telling me I'm back at this branch. Okay. And it gives me some stuff about I'm in a detached head state, and that doesn't really matter. But the point is, now if I look at that residual.cpp, it's gone. That line I added, it was right here. It was right in this spot. It's gone. So I went back in time. Okay. So for now, I'm just going to go back and check out master again. Okay, so now I'm back, and now if I look at residual.cpp, it's there again. So I just went back in time and I came back. So a better workflow, and this is really what Git is made for, and this is a best practice or a rule of thumb, is that I like to, and most developers, like to keep master clean. In other words, master is a branch, right? And you always want master to be working. In other words, you don't want to add new features or develop directly in master. You certainly can, right? But it's a good practice, and Git is really made for this, to branch off of master, okay? And so what I'll do is I'll do that, right? So I'm going to type git branch. I'm sorry. What I'm going to do, what I'm going to do is I'm going to type git checkout. I'm going to put a B there. B means branch. So I'm simultaneously going to check branch and check it out, okay? And so my new branch, we'll call it bug fix. You can call it anything you want. I'm going to call it bug fix because I'm operating on the assumption that I broke my code when I added that line. Right. So I'm going to check out a new branch called bug fix, and you can see my power lines telling me I'm in there. Right. Now I think if you type, this should work now that I tried to use earlier. Yeah. So if I type git branch, so if you don't have this power line thing, if you just type git branch, it'll tell you the branches that you have. There's no limitation on how many you can have. It'll put a little asterisk next to the one you're actually in. Okay. So this is a really useful model. I mean, you saw how easy it was to create that branch. So a good, clean workflow is to always leave master working. And if you want to fix a bug, if you want to add a feature, you create a new branch and you do your work there. And the reason is say I spend 3 hours and I write a bunch of code and it's all junk. It doesn't work, it doesn't do what I want, I can't debug it, and I give up. I just do this, git checkout master, git branch, delete, bug fix. And now if I type git branch, it's gone. Right? So I create a new branch, I go over there, I do my work. It's like a scratch pad or playground. You can do no harm. Right? You can really do no harm in master because you can always go back in history, but it's far easier to just create a new branch, play around, do what you have to do, and if it works, you can merge it, and if it doesn't work, you just delete it. It's like it never was there. And so it's real particularly in the context of software development, it gives the developer a lot of sort of experimental creativity. Oh, I want to try this. Branch, try it. It's 10 times slower than what I thought I was going to be. I'm going to just blow it away and delete it. Or if it works, you merge it in. So let's talk about how to do that. Okay, so let's go back and try it again. We're going to go back and we're going to create a new branch called bug fix. So now I'm in bug fix branch, and I'm going to go fix my bug. Okay. So I'm going to open up residuals at CPP, and we'll just say, my bug was that I didn't want to say hello world. I wanted to say hello Texas. Right. Okay, so let's see what happens here. So if I look at that file, right, residual.cpp, it says hello Texas. If I go back to master, git checkout master, well, I should have done something first. So let me go back. Git checkout bug fix. Okay. So what I want to do is I want to commit that change. Okay. So I'm going to say git commit fix bug. Right. So you'll notice that I'm in bug fix branch, and I have all the history of the master branch because it was the same until I branched it, right? And now I have the bug fix commit up there. Okay? So now let's go back to master. Git checkout master. Okay, now if I type git log, you don't see the bug fix, right? It's not there. Right? And if I look at the residuals.cpp, what do you think it's going to say? It's going to say hello world. Okay? But I fixed my bug over in the bug fix branch. So I can just do this. Git merge master bug fix. Now look at this. Hello Texas. In the master branch. Fixed my bug, my code works again. All right, now I'm done with bug fix. Let's get rid of it. So then I'd say git branch delete bug fix. Right? And then if I type git log, now there's only one branch, so I deleted the other one. So I'm back in master. It's the only branch, and bug fix has been appended to the commit history. Okay. So that's for a bug fix. Something else you might do, another sort of workflow with merging, is you're going to add a new feature. Bug fix is one line. A new feature is 10,000. It's going to take you 3 weeks to write it. So again, you don't want to foul up or developing in master, because you might have users that are pulling down your code from master, and you don't want to pull, there's a lot of prototyping and testing that goes into writing new code, right? And you don't want to foul up your master branch with all this sort of testing and trial and stuff that may not end up in the final version of the code. By the way, just as an aside, never fall in love with code you write. Never fall in love with code you write. Never be afraid to rip out 1,000 lines or 10,000 lines of code if you have a better way to do it. Your code should be under continuous development, always improving, always improving. And that's why it's important to test your code so that as you improve it, you can ensure that it always reproduces the functionality that it did before.
So I have a question. If you delete a branch, can you get it back as well?
No, when you delete a branch, it may be possible. It's just sort of like typing remove on the command line. You might as well assume it's gone. There may be some really hacky way to get it back, but for the most part, you assume it's gone.
As well, if you merge the branch with the master, it's also done, or can you reverse that?
You could do, because you could go back to the commit of the merge and create a new branch from that commit. And that would get you back right where you were. So that would be pretty straightforward to do. One thing is, there's never really a big hurry to delete branches. I want to be clear about something. When you create a branch, it's not copying every file. It's only keeping track of the little changes you made, right? And so it's not. Don't think when you create a branch you're taking your 10,000 files in your source code and making a big old copy and taking up twice as much disk space. That's absolutely not what's happening. It's just, and for that matter, also the incremental commits, right? Git only keeps track of the changes that are made from one commit to the next. It doesn't actually, it doesn't take that residual CPP file and create a whole new copy of it and store it as this version. It just takes the one line. In fact, it just keeps track that we changed world to Texas in its history. So it's a very small thing in terms of memory. So never be worried that you have a whole bunch of branches. So don't be in a hurry to delete them. I have branches that are ancient in some of my source code. Yeah, I mean, basically at point 0, it stores the whole file, and then it changes, and then it stores the changes that go incrementally beyond it. No. I mean, when we get to GitHub in a little bit, I'll show you the Linux kernel. It's 1 million commits. That's nothing. No. Okay. So what I was going to discuss is a new feature. Right? So a workflow for a new feature, a bug fix, you create a branch, you go over there, you change one line of code, you fix the bug, you merge it, right? But a new feature is going to take you 3 weeks to develop, right? So probably along the way, you're going to want to have incremental commits, right? We're going to create a branch, we're going to call it new feature. So we'll say git check out branch new feature, right? So now I'm in the new feature branch, and this is real code that I'm using. I don't really want to mess it up too bad, so I'm going to go into that README file because this is just text. The residual CPP is the code I wrote all day today. It's in a Git repository. I can always go back and get it, but I don't want to mess it up. So we'll just go to the README file, right? Okay, and we'll just pretend that this is just text, but we'll pretend it's source code. So we're going to make changes, and we're going to make changes incrementally. Okay, so we're going to go, on day 1 I hack, and at the end of day 1 I want to, my code's sort of in an incremental state of working. Doesn't do everything I want it to do, but it compiles at least, right? So I want to save that because I don't want to mess that up the next time I start working on it again. So I'm going to go ahead, and I have a way to use git right from my editor. So I'm going to save this file, and then I'm going to say git commit new feature commit 1. That's not a good commit message, right? Okay, and then the next day I'm going to hack. I'm going to save the file. I'm going to say new feature commit 2. So now I have another incremental feature. On day 3, I'm going to hack, and I'm going to save this. And at this point, I'm going to say new feature works. Right? So then if I close this guy. So now if I type git log, you'll see my Git history, right? So we fixed a bug in master, and that's where we branched, right? And then we added new feature. Commit. Okay, now my new feature works. I want to bring it back to master. I want to merge it back into master. However, and it's not so bad when there are 3, but if you're really going to write 10,000 lines of code, it's going to take you 3 weeks. You might have 1,000 commits during that time. Now, are each of those little incremental commits where the code didn't really do what you wanted it to do, but you wanted to save its state because it was compiling at least, right? Your new feature wasn't working, but it did compile, so you wanted to save that, so you committed it, right? But ultimately, is it really important if your new feature works at the end, right, to save all those 1,000 incremental commits in between? Or is it just you just want to save from the way master is now to adding my new feature? That is a more reasonable thing to do, right? And so what you do then is we're going to go back to master. So we'll say git checkout master. Okay, you can see I'm in master. And we're going to say git merge. And I'm going to add a command, squash master new feature. Enter. And now if I type git commit, it's going to open up the editor. And you see it's already been populated with the stuff. And it says squash commit of the following, and all that stuff is there. Okay? It's all the information. And I could keep that, or I don't have to. I can just delete all of this, right? So I could just say gone. And I can type my new commit message. So new great feature. Okay. This is the new feature that I worked on for 3 weeks with 1,000 incremental commits. And now, if I type git log, you'll see all those incremental commits are gone, right? Remember, we had bug fix, and then I had incremental commit 1, incremental commit 2, new feature works, right? I did a squash merge, which means when I did the merge, it squashed all of those commits into one, and then I wrote a new commit message that is more meaningful. Again, because it's more likely that you just want your code to go from where it worked to where the new feature worked, and not all those incremental commits. So it's another workflow you can use with merge squash merges. Yeah.
Is it possible to recover those incremental commits? Like if it breaks something in the master branch?
We haven't deleted new feature yet, right? So we can check out new feature. New feature still has all of those things. Right? So what I could do is I could go back to master. I could revert. This is one I don't know how to do off the top of my head, but let's see. So I could do git checkout master. And keep your fingers crossed. We're going to say git revert. Git log. Oh, it didn't work. Git reset. Git log. So I don't know. I'd have to Google. I don't know all the git commands. I'd have to Google. But the idea would be, it's one of those reset or revert. It's probably the syntax wrong a little bit. I could take and I could basically wipe out that commit, and then I could redo another merge. Not this time, maybe not squashing it because you want to keep all those incremental. Right? So yes, as long as you don't delete the branch, there's always a way. So Git is, everything I talked about so far has really just been associated with your own software project. But the real utility of version control is when you have big teams of people working on the same code. Right? Now, what if you and your teammate are working on, and we'll talk a little bit more about sort of centralized repositories and other things, but we could have sort of a repository in the cloud that's an exact clone of this, right? And so then I have a clone and my teammate has a clone, and we're under a huge deadline to fix a bug. It's a bad bug. We need to get into the next release, whatever. We're both working on it simultaneously. We're talking to each other. and we both fix it at the same time in different ways, and we both commit. What happens? Well, let's see. Let's see what happens. So let's go back to residual CPP. Okay. So I'm working on it, and I'm going to do something bad, but I'm going to work on it from the master, and I'm going to change. Well, we deleted bug fix. First we need to, let's create a branch bug fix. Okay. So I think we did, right? Yeah. So we'll get rid of that new feature branch just to keep things clean. Oh, it says something, but it's no big deal. Okay, so we're gonna check out a new one that we'll call bug fix 2. What did I do? Branch. Okay. So now we're in bug fix 2. Go into residual, and so I'm going to play the role of my developer teammate, and he finds the bug, and he says, "Oh no, it's not supposed to be Hello Texas. It's supposed to be Hello New Mexico." That's where I used to live. Right? Okay, and so then I'm going to commit that, or he, my teammate, I'm playing the role of my teammate, so he commits that. Fix bug. Okay, and then let's go back to master, where I'm working against my own advice. Okay, so I'm working on this right in master, where it says Hello Texas. I said, nah, that should be Hello Nevada, where Las Vegas is. Okay, so, and I of course need to commit that. So I think I fixed the bug, and my teammate thinks he fixed the bug, and we both edited the exact same location of the file at the same time, right? So I beat him to the punch, and I checked mine into master because I was working there. I claim it's the bug fix. And then he comes along after me, and he says, okay, git merge master bug fix 2. Oh no, Git's telling me there's a merge conflict. So I need to open up residual CPP, and lo and behold, it tells me exactly where it was. So if you look, so it says in head, which is essentially master. So in master it says Hello Nevada, and in bug fix 2 it says Hello New Mexico. Which one do you want? So since I'm right and my teammate's not, I'm going to choose Nevada, also because that's where Las Vegas is. And right quit, git commit, fix merge conflict, and git log. So it's smart enough to know and inform you when there's merge conflicts because you're making changes at the same time. It's also smart enough to know that if 2 people are working on the same file in different places, it'll automatically merge it. And in fact, sometimes I write papers with my students in LaTeX. Anybody know what LaTeX is? Typesetting language, right? And we use Git and GitHub as a collaboration to write those papers. And so what'll happen is, I'm working on the first paragraph of the introduction, and he's working on the 3rd paragraph of section 12, adding some equations, and he commits and I commit, and it just magically goes into the same file, and no problems. We don't even have to worry about it. Right? If we were to both be editing a paragraph 1, and our edits stomp on each other, then it would do what it did there. It would inform us that there was a merge conflict and allow us an opportunity to fix it. So with that, I think that's sort of basic Git. It's way more powerful than that. But the idea would be, branch a lot, right? use your branches a lot, right? So now let's spend a little bit of time and talk about GitHub. So GitHub is a cloud platform for software development. It's probably the most famous, but there are also others that have very similar features, namely Bitbucket and GitLab. Okay, so these are websites that have certain free features for developers. Also have some more, for more features you can pay. These are typically for organizations or large teams. For most of the things that you would do in a small group, you can use the fully featured things for free. Okay, between the three, GitHub and Bitbucket and GitLab, really the differences are just in the pay structures and how they charge you for stuff. Okay, so this is sort of the homepage of GitHub. If my profile's here. These are a bunch of repositories. You can see I've made 443 contributions in the last year. That doesn't actually seem like a lot for me. I used to always have 1,000 in a year at least. These are different repositories. I think I have 80 something I've contributed to over time. So I've been a member for quite a while now. And I think if you want to be a computational scientist, I think GitHub should be your resume. GitHub, Bitbucket, whatever. You can put, of course you got to have a resume. But if I'm going to hire you, and you hand me a piece of paper that says you know C++, I'm going to be like, oh, really? Okay. Or you can show me your GitHub page. You can show me the 17 pieces of code you've written contributed to the last year, right? I can go in and I can look exactly what the commits associated with you. You can send me an email and say, this is my, these are my contributions. By the way, one cool thing about GitHub is those IPython notebooks, Jupyter notebooks that you guys looked at, it renders them. It renders them. So that's a source code file that it renders in the screen. So all that is, I uploaded the raw file, the IPNB file, and it rendered it, including the math, everything. So that's kind of a cool thing. So in this case, you can point your future employer to your GitHub page and show them all the great software you've written, and that's far more convincing than writing I know C++ on your resume. Okay. Well, how do we use it in the context of what we've been doing? Right? So again, this is really in the context of teams. You want to collaborate. Okay. So if I'm just versioning a Word document on my computer, I don't upload it to GitHub. Although sometimes it's a convenient backup. You can think of it like a convenient sort of a Dropbox for code. And another good thing is a lot of us work on supercomputing. We'll do some work locally, right? And then you want to move that work to your supercomputer. On this campus, maybe Stampede. And then maybe you get over on Stampede and you realize, oh no, I found a bug in my code, and you want to make sure it's all. So what you can do is you can keep your code on GitHub, and you can push and pull the changes from either side, from Stampede or from your local computer. You can keep everything in sync really nice, right? Without a lot of transferring files back and forth and stuff like that. Right? So I want to create a new repository. So in this case, we're going to create a new repository, and the repo name will be inextensible beam. I think I've already created this for a paper I'm writing. Let's say inextensible beam code. Right? So now that works. I'm going to let it be a public repository. I can initialize it with a README. I already created a README in our repo, and so I can create the repository. All right? Now it gives me some options. So if it's a brand new repository, it gives me some code that I could copy in, and then I could pull it down immediately. Or since we already have an existing repository, it says basically copy this line into your file, which the first one adds a remote. Basically, it tells your Git repo that now you have a repository in the cloud that you're going to stay in sync with. And then this actually pushes it there. So the first one adds the information about what the default name is origin. Right? And the second one would be, I'm just going to type it, it's git push origin master. Okay. And so when I go over here, when I refresh this page, there are the files that we've been working on. And the README is rendered, right? So remember we wrote this little README, inextensible beam FEA code, and this hack nonsense, right? And then there's the codes, there are the files that we stored. Residual CPP, inextensible beam, MyPython notebook, right? And we can go in there and we can see that we did this. So this is the code, and somewhere in there is our print statement. Right there, hello Nevada. Right? So what we can do is I can actually go to Stampede and I can clone this, and I can make changes there. So we'll go back to here. If I look right here, there's a tab that says clone or download. So I'll say clone. I want to clone, and I'll use this SSH protocol. So I'm going to go back over here. I'm going to SSH into Stampede. Okay, and then, so in here, I'm going to run git, well, I need to say git clone that thing. Oh, I need to, I have to probably do it with a, I want to use HTTPS. Right, so let's try it again. So now I'm on Stampede, git clone. Why did it do that? Disk quota is exceeded. Really? I've probably just got 5 or 10 more minutes of stuff I want to cover. I'm not sure why this is taking so long here. A slow network or something. Try one more time. Okay, I got it. So there's my inextensible beam code. I can go in there. So I'm logged into Stampede right now, right? The supercomputer. And now I can make changes. So like, I don't really want all that hack stuff in my README. So I'll go in there, I'll take it out, I'll write it, I'll commit it. And I'll push it back, origin, master. Yeah, I think you have to do some setup on Stampede to be able to do that. But ideally, I would just push that back and those changes would get fixed, okay? So that's just one way to, I'm sort of collaborating with myself in that respect. The other thing you really do, the proper way to use GitHub in a team environment is you fork the code, okay? So you see this thing up here? So a fork is sort of like a copy in the cloud, if you will, right? So what I'm going to do is I'm going to click that fork. And I can't fork it to myself, but I'm a member of several organizations here. So I'm going to click, say, this PGE thing. And so it forks it. It's working on it. And now you see, instead of just John T. Foster, it's in this John Foster PGE.utexas. And it says forked from that thing, okay? So now what I can do is I can go in and, so again, a fork is like a copy in the cloud, right? So it's a little strange what I'm doing here because I like copied it myself, but usually you'd have Jack and Harry, right? And they'd each have, Jack wrote the original code and Harry forks it, right? And then so then what Harry would do would then pull down the code to his computer. And in this case, what I'll do is, I'll just go to I'll get off of Stampede. I'm going to go to my desktop. And I'm going to type git clone. So now I've cloned this inextensible beam, and now I'm going to make some changes. How about I go in and fix that thing? I'm just going to get rid of that line. I'm going to try to get my code back to where it was. I'm going to go into the README, and I'm going to remove the hacks because I don't want those in there. Okay, and then I'm going to commit these changes. Take code back to original state. Okay, and then I'm going to push it back to origin master. Okay, now if I go over here, right, so this is, again, understand what's going on. This account, John Foster PGE U Texas, this is that account's thing. And so if I go in here and try to zoom out on this, I don't want, but anyway, if I refresh this page, you see the hack stuff is gone, okay? But if I go back to my, the original version, right, they're still there, okay? So one account fixed it, the other one's still there, and what I want to do is the other account that fixed it, I want to get those changes back to the original, right? So this is where you do something called a pull request. So I'm going to go back to the account where I fixed it, and if you look right here, where is it? New pull request. So I would click that, and it's going to tell me exactly what the changes are. So it says, I removed, that's red if you can't see it. It says I removed those hack lines, and I removed that line, okay? And I could put some additional comments in if I want. So I create the new pull request, and hey, I fixed your code. Create the pull request. So then back to the original one. So now I'm back on my real account, right? So this is not this organizational account, but my real account, right? So then I can go here, go to the inextensible beam thing, and right up here I should see somewhere, oh, right there, pull requests. Hey, I got a new pull request. I go in here, click on this. Oh, somebody fixed my code. I can review it, so I can go in and I can look at the changes. I can go look at the commits and exactly what files were changed. 2 files were changed. I can review them. So I can review, I can see exactly what was changed. Oh, okay, yeah, that really should be like that, right? And so then ultimately, what I could do is I go back to the pull request and I would say, merge this pull request. Confirm the merge. Now, go back to my code, and the hacks are gone. The code is back to its original state. Okay? So again, this is for a collaborative environment where you're working on things as a team, and the workflow would be, if you have one master repository that either belongs to your lead teammate or to possibly an organizational account, you fork to your local account. From your local account, you clone to your computer. You make your changes, possibly branching and doing all that other stuff we talked about. You add your new feature, you merge, you push back, you create a pull request, and it goes back. And then someone can review that pull request and either merge it or discuss it, request additional changes. If additional changes are requests, all you actually have to do is push back to your forked account, and those changes will automatically propagate over. And so the idea here, and all of this stuff really adds to code quality, because if you work in a team like that, it's really good. I work in a team environment where I have permission to submit code directly to the master repository. And occasionally, if it's a small bug fix, I do that. I just commit it right into the master repository, and that's fine. But if I have a big new feature I'm adding, even though I have permission myself to merge my own pull request, to submit it in there, I never do that. I will submit a pull request and have one of my teammates take a look at my code. And this does a couple things. I mean, one, it adds to code quality because you get additional eyes on it. Another thing, what just surprisingly, over time, the code base will become more uniform and more readable because everyone, all the teammates are always looking at each other's code, seeing how they write, adopting best practices, discussing things, and eventually the code base will become more uniform. If it's more uniform, it's more readable, and all these things are, eventually lead to best practices and stuff. So again, I think we'll stop there with Git. I mean, this is just part of what good developer operations are. And Git interfaces really well with some continuous integration services, notably Travis. So a continuous integration service would be something where upon every commit, your continuous integration server is looking at your repository all the time. And when it sees a new commit, it pulls your code down, it automatically builds it, it runs a test suite to make sure it's doing what it always did, and then it sends you a message, or it sends your team a message. Right? It says, your code's working great, or it says, you broke the code, you need to fix it right now before some user gets it and complains. So anyway, I'll take some questions if there are any.